Hello children, welcome back. Children, we already know about the sets. A set is a collection of well-defined objects. Now, what we can do with the sets and what are the natural operations on them? Yes, when two or more sets combine together to form a set under the given condition, then the operation of the sets can be carried out. John Venn was an Englishman who invented the Venn diagram. Now, what is the use of this Venn diagram? It helps us to visualize the relationship between the sets and set operations. It pictorially represents the relationship between the sets and set operations. Now we are going to see that four operations, that is union of set, intersection of set, and difference of set and complement of set. To understand the Venn diagram, we are going to take two sets. First, a set of people who loves football are A, B and C, and a set of people who loves cricket are B, C, D and G. Children, how can we represent this in a Venn diagram? Yes, let A is the set of people who loves football and their elements are A, B and C, and B is the set of people who loves cricket are B, C, D and G. Now children, let us express in a circle. Now let us put the elements inside the circle A, B and C. Same as well as put these elements inside the circle as B, C, D and G. Now you may ask the question, what is the purpose to put these elements inside the circle? What is the use of writing these elements inside the circle? It helps us to understand the union of set and intersection of set. Children, now looking at these two sets, okay, that is football and cricket, are you able to observe the people who loves football or cricket or at least any one sport? Yes. So to find, we are going to find A union B, which means A or B or both. So the people who loves football or cricket, so what are the elements we get? Yes, A, B, C, D and G. Here we can observe it, B and C, they loves football and cricket. So we don't want to write it again, it's enough to write one time. So what? Now children, now looking at these two sports, can you able to observe the people who loves football and cricket? What is the common thing? Yes, B and C who loves football and cricket, they loves both. They love both football and cricket. And what are the common thing? Yes, B and C loves football and cricket. So for this we are going to take an intersection. So A intersection B, we get the elements as B and C. So mathematically it can be represented as A intersection B is equal to X such that X belongs to A and X belongs to B. So when you combine this together, we can call this as overlapping set. Okay. So A union B is equal to B union A, same as well as A intersection B is equal to B intersection A. Children. Now children, let us move to the next topic, difference of two sets. If A and B are any two sets and their difference is A minus B is the set of all those elements which belongs to A but doesn't belong to B. Similarly, B minus A is the set of all those elements which belongs to B but doesn't belong to A. Children, it's very easy, remember it, A minus B means that all the elements belongs to A but doesn't belong to B. Similarly, B minus A means that all the elements belongs to B but doesn't belong to A. Let us take an example. A is the set containing the elements 2, 3, 4 and B is the set containing the elements 1, 3, 5, 7. Now what is A minus B? Yes, A minus B means the elements which belongs to A but that doesn't belong to B. What do you observe it here? Yes, 3 is cancelled. Why? Because it is in B. So we are not taking that. So we get A minus B as 2, 4. And similarly, what is B minus A? Yes, we get the answer as 1, 5, 7. Okay. So from this conclusion, is it A minus B is equal to B minus A? No. A minus B which is not equal to B minus A. Children, let us write the set builder form. A minus B is equal to set of all x such that x belongs to A and x does not belong to B. Similarly, B minus A is equal to set of all x such that x belongs to B and x does not belong to A. Hello children, welcome back, and today's topic is complement of set. The complement of any set A is the set of all those elements of the universal set which are not the elements of A. Children, I repeat once again, the complement of any set A is the set of all those elements of the universal set which are not the elements of A. Children, the complement of set can be denoted as A dash, which implies not in A. Let's take an example and you will understand the complement of set. Let U be the universal set containing the elements 1, 2, 3, 4 and 5. And A is the subset containing the elements 1, 2 and 3. Then the complement can be written as A dash is equal to U minus A. So we get A dash is 4, 5. What do you understand from this? Yes, that all the elements of the universal set which are not a part of set A. Children, let us understand with the help of Venn diagram. Let U be the universal set and A is the subset containing the elements 1, 2 and 3. Children, you can observe it clearly that all the elements of part A, which means set A, are written inside the circle. 1, 2, 3 are written inside the circle, but the elements which are not a part of set A but a part of universal set are written outside the set, that is 4 and 5. It can be mathematically represented as A is the set of elements x such that x belongs to U, x does not belongs to A. Hope you understand the complement of set.